Hey everyone, welcome to our channel. I'm Monica, a mechatronics and automation student at VIT Chennai, and here I'll be solving 5 frequently repeated questions from the current electricity chapter for JEE. These patterns are likely to appear in the upcoming exams, so stay tuned and make sure you are prepared. Now let's get started with the very first question. A wire of length 10 cm and radius root 7 into 10 to the power minus 4 meter connected across the right gap of a meter bridge. When a resistance of 4.5 ohms is connected on the left gap by using a resistance box, the balance length is found to be at 60 cm from the left end. If the resistivity of the wire is R into 10 to the power minus 7 ohm meter, then the value of R is. This question was asked in JEE Mains 2024. So, to know about this, let's first understand the basic concept of meter bridge. Sorry for this bad drawing, but please adjust. So here is where your known resistance will be placed, and here we'll be placing our unknown resistance. Say this is X and this is R. This one is known, okay, and this one is unknown. And here is where our galvanometer will be placed, and this is the null point. Okay, so what exactly is a null point? Null point is the position on the wire where the galvanometer shows no deflection. This occurs when the ratio of resistances in the two arms of the bridge is equal, and this is indicated as a balanced Wheatstone bridge. Okay, so we will take this length to be L and this one to be 100 minus L, because the length of this whole scale is gonna be 100. Okay, so the formula for this one is R divided by length from the left end, which is L, is equal to X, which is the unknown resistance, divided by 100 minus L. Okay, and this is the formula, as you know very well, is the balanced Wheatstone bridges formula. Now let's solve this question. They have given the known resistance to be 4.5 ohms, and from the left end the length is found to be 60 centimeter, and we have also been given with the resistivity to be R into 10 to the power minus 7. Now let's solve the question. The R which is known is 4.5 ohms, length from the left end is 60 centimeter. X is the resistance which we'll have to find out, and 100 minus L, 100 minus 60 is 40. X is, let's say it is X itself. But we have been given with resistivity. Okay, so what we're going to do is R is equal to rho L by A. We know this formula, right? So R is nothing but this X, which is the unknown resistance, and L is 0.1 meter. Why am I taking that to be 0.1? Because they have given the length of the wire to be 10 centimeter. So converting centimeter to meter, we get 0.1 meter. So rho is gonna be as it is into 0.1 divided by A. We have been given the radius to be root 7 into 10 to the power minus 4 meters. So A is nothing but pi r squared. So pi into r, radius is root 7 into 10 to the power minus 4, right? Yeah, it's minus 4 squared. So you get rho into 0.1 divided by pi into 7 into 10 to the power minus 8. Substituting this one over here, we get 4.5 divided by 60 is equal to rho into 0.1 divided by pi into 7 into 10 to the power minus 8. So solving this one, we get rho is equal to 66.67 into 10 to the power minus 7 ohm meter. And we have been given here that if the resistivity of the wire is R into 10 to the power minus 7 ohm meter, that means the resistivity we have got is this one, and they've also have given this here, this one. So this is our R. So the approximate value have been given here. So the answer is option C, 66 ohms. I hope this question is clear to you now. Now let's move on to the next question. Okay, this question was asked in JEE Mains 2024. The question says, a wire of resistance 20 ohms is divided into 10 equal pairs. A combination of two parts are connected in parallel, and so on. Now, resulting pairs of parallel combination are connected in series. The equivalent resistance of final combination is. So actually this is a very easy problem. Let me solve this one. Okay, they have given that there is a wire of 20 ohms. Say this is the wire, 20 ohms is divided into 10 equal pairs. So it's gonna be 20 divided by 10, because they have given us 10 equal pairs, so it is gonna be 20 divided by 10, which is 2 ohms each. So we'll have 10 wires of, say there are 10, okay, 10 wires of each containing the resistance to be 2 ohms. Now they are saying a combination of two parts are connected in parallel. So we'll be taking two wires each and we'll be connecting them in parallel. Okay, and the next line says, now resulting pairs of parallel combination are connected in series. So the resulting pairs of parallel combination are then connected in series. So it'll be like this. One pair, that is 5 pairs are connected in parallel, then those combination, that is parallel combination, are then connected in series. So it will be like this, right? Okay, so this will be 2 ohms. So solving this one, we'll get 1 ohm. This one will also be 1 ohm since they are in parallel. 1 ohm, 1 ohm and 1 ohm. So since all of these are in series, the resulting one will be 5 ohms. Right, so 1 plus 1 plus 1 plus 1 equal to 5 ohms. So the answer for this one is 5 ohms. Okay, moving on. Question 3 says the equivalent resistance between A and B is. So we'll have to find out the equivalent resistance between A and B. Okay, to solve this kind of question, what you'll have to do is forget that these A and B are terminals, but think them to be positive and negative terminals. Okay, that is your battery. I'll roughly draw the diagram now. Okay, so this one is 6 ohms, 10 ohms, 5 ohms, 7 ohms, 8, 11, 4 and 8 ohms. Okay, so we know that current flows from the positive terminal to the negative terminal, right? So the current now flows from this end, it goes, and there is a junction over here, as you can see, because there are two wires that are being connected. Okay, so the current that flows through the 6 ohm resistor gets divided. Okay, so they say this one is I current and this one is I1 and I2. Okay, remember this one. Okay, better I'll write this in a different color, green. Okay, I current flows through 6 ohm resistor, gets divided I1 and I2. Okay, you know this concept very well, that in parallel circuit, I varies, whereas in series I is gonna be constant or same. Okay, this I current now flows through the 10 ohm resistor and then moves to the 5 ohm resistor. There is no division over here, there is no interconnection of, there is no junction of wires that are being connected here. So the I current flows directly from the 10 ohms to the 5 ohms. Okay, there is no change in current. Hence I can say that here the I current, that is the I1 current, is the same, and hence I can say that 10 ohm and 5 ohm are in series. So I can very well add them up according to the series connection resistance formula, right? So I'll write that down. I'll convert it now. Okay, so this is gonna be 10 plus 5, 15 ohms, and the rest be as it is. Sorry for this very bad diagram. I'm a little bad at drawing. But I hope it's clear. Okay. Now, okay. The I1 current flows through this one. Okay. Now let's just leave this I2. Okay, because if I explain you with this I1 current, it'll be very much easier than with explaining using this I2. Okay, so I'm just leaving this I2 current. Now this I1 current moves to the next part. See, here is a junction connecting this wire and the 7 ohm resistor wire as well. So what happens here? The current again gets divided. Here goes the other I1. This here goes say I1 dash, and here goes I1 double dash. Okay. I1 dash, and here I1 double dash. So this I1 double dash then travels through this 7 ohm resistor and then across the 8 ohm resistor as well. But since there's no interconnection of any wires, the I1 double dash current just moves through both of these resistors as it is. So the I1 double dash remains constant throughout these wires. So these ohms are gonna get added since they are in series. As you know very well, the I1 double dash hasn't been changed. Seven plus 8 is 15 ohms. Okay, now this 1 minute, I'll change the color. Okay, this I1 double dash moves from this 15 ohm resistor towards the 11 ohm resistor, but as you can see very well that there is a junction over here as well. So again what happens is that current gets divided. So what I can say is that this 15 ohm resistor and this 11 ohm resistor are in parallel because the current is getting divided. And same here as well. 15 ohm after the I1 current got traveled from this 15 ohm resistor towards this 7 ohm resistor earlier, there was also a current division here. This I1 current turned out into I1 dash and I1 double dash, right? So this 15 ohm resistor is in parallel with this 7 ohm resistor, and yeah, this 7 ohm resistor and 8 ohm resistor are in series, and hence we converted them into 15 ohm resistor. And now I can very well say that this 15 ohm resistor, this 15 ohm resistor are in parallel. Since these are also in parallel, then I can very well say that all these three are in parallel. See, the current I1 double dash gets converted to I1 triple dash and I1 say I2. Okay, then the I2 current travels through this 11 ohm resistor and then through this 4 ohm resistor. Since there is no current division, hence 11 ohm resistor and 4 ohm resistor are in series. So that's gonna be 15 ohm resistance. Okay, so 15 ohm resistor, 15 ohm resistor, 15 ohm resistors or in parallel, and this I2 current flows through this one, through this wire, and here is our I1 triple dash, which converges over at this point, and hence I can say that 8 ohm resistor and a 6 ohm resistor are in series. So I'll convert this circuit diagram, into a more simpler one so that it will be easier for you all to understand it. Okay, these are your 15 ohms, and here is our 8 ohm and 6 ohm. These are in parallel. these are all in parallel. Okay, this one will be 5 ohms, as you know, 1 by 15 plus 1 by 15 plus 1 by 15 is equal to 1 by R, and solving this we get R to be 5 ohms. Okay, so that will be 5 ohms, 6 ohms, 5 ohms and 8 ohms. All of these are in series, and this gives you 19 ohms. So that's the answer. The equivalence at A and B. When you solve this whole thing, this whole question, that will be your equivalence for A and B. Okay. So the answer for this one is option B, 19 ohms. I hope this question was clear to you all. Since this video turned out to be a bit longer, I'll be splitting it into 2 parts. Stay tuned for the next video where I'll be covering the remaining questions.